Hi, in this video we'll study about mixture models. So mixture models allows us to describe a probability distribution by a convex combination of some simple probability distributions. So basically let's say we have P1x, P2x up to pkx, some k probability distributions, and we can take the convex combination of these k probability distributions. So sigma pi I pix from I is equal to 1 to k. So this is the convex combination of these k probability distributions such that sigma pi I is 1. And this convex combination of the probability distributions would be a distribution itself, and let's say this distribution is px. So mixture model means we have to model the probability distribution, and this probability distribution which we want to model is itself a mixture or combination of other simple probability distributions. And when this probability distribution, the simple probability distribution pix, follows a normal distribution, let's say with mean mu I and variance matrix sigma I, then this mixture would be the mixture of Gaussians. So our px here would be a mixture of Gaussians, and the aim of the Gaussian mixture models is to model the mixture of Gaussians, that is model px such that px is a convex combination of a particular number of Gaussian probability distributions. So the goal of a Gaussian mixture model, so the aim is to obtain k Gaussian distributions, that is parameters mu k and sigma k, and second goal is to obtain pi i's for I is equal to 1 to k, so the sigma pi I is equal to 1, such that we can approximate the distribution of the given data using px, where px would be pi I normal distribution of x, given that the normal distribution has mean mu I and variance sigma I for I is equal to 1 to k. So probability distribution of, so the probability function for any given value x is a convex combination of probability distributions of individual Gaussians, where every Gaussian follows a different mean and a different variance. And to estimate these parameters pi I for I is equal to 1 to k, mu k, mu I, and our goal is to estimate pi I, mu I and sigma I for I is equal to 1 to k for our k independent Gaussian distributions. So let's see a quick example. Let's say we have data something like this. If we visualize this data, we can identify that it can be broken down as into three normal distributions. So the first distribution is here, The second distribution can be this one here, and the third distribution can be this one, where dot represents mu i's. So this is, sorry, so this represents mu3, this represents mu2, this represents mu1, and for any given x, where x is basically x1, x2, the probability density function px is pi1 into normal distribution of x, assuming mean is mu1 and variance matrix is sigma 1, plus pi2 into normal distribution x given mean is mu2, variance is sigma 2, plus pi3 into normal distribution x given mean is mu3, variance is sigma 3. And the goal is to estimate pi1, pi2, pi3, mu1, sigma 1, mu2, sigma 2, mu3, sigma 3. And to estimate that, we will follow something called as EM algorithm, and we'll go into the details of EM algorithm in our next videos. I hope you'll like this video. See you in next video.